This is the 7-3 day 3, integration by parts. We're also going to do some seeing how it applies twice, and then also working with some initial value problems. This is the warm-up, so at this point pause the video. The third one's multiple choice. Come back only after you've gotten them worked out yourself to check. Okay, if you're back, I presume you've tried them yourself to make sure that you can do them. So take a look, and we'll slide the screen up and down a little bit. So you can see mostly on number 1, you want to be looking at U substitution. Same for number 2 after you rewrite the function. So 1 and 2 have nothing to do with integration by parts. You have methods you can do those by. Number 3 is an integration by parts. So again, freeze the video, look at whichever ones you need to before you go forward. So in 7-3 day 3, we're going to do more integration by parts. We're calling it Deja vu because you may need to do it more than once in some of the problems we're going to look at today. And then go back and get some initial value problems brought in, some of the things we had done before when we studied integration. So at times when you integrate by parts, you will get an integral as part of what you do that needs to be done by integration by parts. Again, in other words, an integration by parts problem inside of an integration by parts problem. So to show you what I mean, we've got the example of the integral of x squared e to the x dx. As we go through and pick to do this by parts, we would pick by Liate to pick which one we're going to use for u, and algebraic comes before exponential, so we pick x squared, so our du would be 2x dx. The rest of it then, our e to the x dx would be our dv, leaving our v at e to the x. So as we go and substitute in to get the value of the integral, we'll have e to the x squared minus the integral of, and there's our v times our du is going to get us 2x e to the x dx. That integral needs to be done by parts. So as we look at that and see that that's what we need to do for this resulting integral in here, we need to do the whole process again, and you do not want to switch which functions or types of functions you made your u and your dv. So that's what this big warning is you need to do it again. You don't want to switch the types of functions. So my du, or my u, is going to be my 2x function, my algebraic function. Once we're down to a constant there, we should be feeling pretty good that an end is in sight. So our dv then is our e to the x dx once again, which again has a nice, easy antiderivative. So as we go to do this, here's the part that mixes people up and they often end up with incorrect signs. The next thing that I subtract has to be everything that came from that integral. So as I go to do integration by parts for this last integral, I need to make sure that subtraction gets carried through. So there's my uv minus the integral of 2 e to the x dx. So my final integral value for the entire thing, subtract that 2x e to the x. And when I go to do the integral here, I'm going to bring that 2 out front, but I've got to subtract here and a subtract here to distribute. So I'm going to add 2e to the x, and then our constant, so that we have our final integral. We'll try one more with that so you get the idea. So in this one we've got an x squared again, and we've got a cosine. Trig is one of the last functions you want to pick for u. So again, by Liate, I'm picking my u as my algebraic function, and leaving my cosine of, I'm going to rewrite that as half x dx over there. You might want to think of this one as a u substitution situation to get your v, so I'm going to be thinking about what the integral of cosine of 1/2 x is. 1/2 is going to be my u, so I could really use a half sitting out front in order to complete this. So when I go to get my dv, and again, pause the video and work that if you need to, we'll end up at 2 sine, and again, that 1/2 x gets brought in. So as we go to sub all this in, we're going to come across with our 2x squared sine of half x minus, and then we've got our nice integral. And our integral is going to have our v times our du, so we're going to get 4x cosine half x dx. This resulting integral sitting right here, we're going to use integration by parts again in order to carry that out. So I'm going to bring down the entire first quantity. Subtract and open a giant parentheses for what comes out of that integral. As I go to pick again, the Ate says stick with your algebraic here, don't switch, stick with your trig as your dv. Again, if you need to do a little u substitution so that you can get your v worked out, pause the video and do that. Then coming back and putting that into the next integral, remembering we're going to have to subtract everything that comes out of this. So our u times v is our negative 8x cosine of half x. Subtract that integral. We've got a negative 8 cosine of half x dx. Again, working your integral, if you need to go do a little bit of u substitution so that you can see how that comes out, go over on the side and do that, and that's going to take some patience when you're doing homework. So final answer here, and let me move these guys over and out of the way for a second. We're going to end up with a minus 16 because we've got a minus here that's going to distribute to the minus here and a minus sitting in there. And there's our final integral. One last thing, when we did integrals the first time, you did what was called initial value problems, and in your initial value problems, they always had you do an integral, but then they wanted a specific function, not a generic one where we have a plus c. They wanted a specific constant that we would work out from given information. So as we take the one that's here, and we need to first move that differential over, so that we actually have an equation we can integrate. Make sure that there's no sloppy algebra or calculus. We need the dx on the other side in order to integrate. So we're looking for the specific y function for whom this integral works. So we want to be thinking about solving that derivative or solving that integral. So again, I'm going to go for parts. Okay, always choosing the natural log if it's available as our u, and our dv then is going to be that x cubed dx, which really means we've got a 1/4 x to the 4th as our v. Again, pause and do whatever you need to so that you can work these through. We get there's just plugging into our parts. We're going to get a bell here in a minute, so just ignore that loud buzzer when it rings. Okay, cleaning this up. The 1/4 can come out front, and one x factor here knocks out one x factor here. So we're really going to be integrating x cubed. We have a 1/4 constant that came out front. The integral of x cubed is 1/4 x to the 4th. We need to add our constant. Now we can start to put in the information that they gave us at the top at any point, but I'm going to clean mine up just a little bit before I do that. So I have the generic or the general solution, as we called it. That's the function in general. Then they gave us information and they said that y's got to come out as 5 when x is 1. And we've got to find out what that constant is. Now, being really careful here because this isn't your calculus, natural log of 1 is 0. So that zeroes that whole term out. So we end up with 5 is negative 1/16 plus our constant. So our constant is 5 and 1/16 or 81/16. going back then and writing our specific solution, meaning a specific function for which we had its derivative. And then we're going to tack on that constant of 81/16. So your assignment tonight comes from 7-3 day 3. So make sure that as you're doing the problem numbers, check syllabus or check lesson plans for those.